Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition. Hello and welcome to our Lunch and Learn, as we will be joined by Iscar. I'm Jake Kaufman, a managing editor at GIE Media's manufacturing group. We'd like to thank Iscar for being today's sponsor. Iscar is a full solution provider of metal cutting tool products and accessories for CNC machining. Launching hundreds of new products for machining each year, Iscar is where innovation never stops. Today's presenter is Thomas Rohn, the Chief Technical Officer at Iscar Metals, the U.S. subsidiary of Iscar. Tom has 31 plus years of manufacturing experience in the industry, starting in 1991. Tom has spent 12 years as a CNC machinist and CAM programmer, mainly working for companies within the die and mold industry. Tom joined Iscar in 2003 and is focused on product management while engaging with manufacturing companies throughout the U.S. to improve CNC machining processes through education and implementation of cutting tool technologies. Tom currently leads a team of cutting tool product specialists responsible for developing and articulating cutting tool application strategies that improve productivity for the customers. Now, Tom, thank you once again for joining us here at GIE Media, and definitely looking forward to seeing what is out there from Iscar. So the floor is yours.
Great. Thanks, Jake. Once again, appreciate the opportunity to join you and everyone who's on the call. Thank you for joining us today. So we're going to talk about right-sizing cutting tool solutions for light-duty spindles. And today's agenda, we will cover clarifying what our definition is of a light-duty spindle and just looking at some of the typical applications that we see on these spindles. When we'll look at the overall cutting tool solutions, and look at it from a utilization perspective. That's something that we feel is very important to be as productive and make the most of your investments in the tooling that you're purchasing. And then putting it all together in an assembly to be as productive as you can be. And part of creating that assembly for rotating applications typically involves creating that assembly, whether it's adding a holder or adding an ER32 type collet. We'll just look at how to put it all together and be as productive as you can with these cutting tool environments. So our definition of a light duty spindle. So we have your typical BT30 environments. Robo drills have become very popular in the market. We have other machines that have the HSK smaller diameter tool holders like the HSK32 and the HSK40 type. And, we're seeing more of these in the market. The trend towards less material removal, which I'll elaborate on further in a few slides, and more speed, less horsepower. It's just one of the environments that we're seeing improve or increase out there in the market. And of course, Swiss machines, they've been growing in popularity now for a number of years consecutively. And with those machines, we have the typical ER stations for rotating tools, whether they be milling or hole making tools. And we're starting to see more C3, C4 in these machines, and maybe some B-axis capabilities in some of the more or some of the later technology, more advanced machines. So there's a lot of small tool holders there that can be employed in those environments. And then when you get into the lathe environment, driven tools for a long time now, depending on the capabilities of the driven tool holders, you can easily overtax or try to do something that isn't productive on these machines. But if you do match the tool up with the tool holder and its capabilities, you can get a lot of nice performance and do a lot of like done in one type scenarios on a lathe with milling and hole making tools. And then looking at milling attachments in general, whether it's a right angle or some different angle or getting into a tight area, these milling attachments, sometimes they can be other configurations, but the ER type is very popular out there in the market. So being able to configure different milling and hole making tools into these types of attachments and having some quick changeability can be very beneficial. because a lot of times once these are set up, if you can simply index and insert or change a head, it's very quick and beneficial for your operating efficiency of your equipment, the OEE aspect, if you will. So looking at some of the drivers that we're seeing out there in the market that are leading us to talk about this today, we look at metal additive 3D printing. It's amazing to me how quick this is moving, because when I came to the cutting tool industry a little more than 20 years ago, I came from the die and mold market, and we were just starting to implement 3D printing of prototypes rather than making single cavity molds and doing the prototype work in a molding type way. And I remember coming to Iscar and thinking, well, I wonder, how much longer we'll have a job or an impact in the subtractive world. But, it seemed like maybe on the resin side or in plastics that 3D printing, advanced pretty well in that first decade that I was here with Iscar. But now in the last 3 to 5 years of being, looking at different technologies and additive and subtractive, and yeah, we're really starting to see the metal additive picking up, and different industries are driving that. And then you look at the precision casting and forging environment. There's been precision, castings and forgings, for quite some time, and I'm sure they continue to evolve and improve. And all that leads to less material to take in a subtractive process. And this is being driven by industry. The main industries out there, whether it be automotive, aerospace, medical, these companies are innovating and implementing new technologies. And these parts, that I guess I never really thought that I would be on an airplane or hearing about devices that are in spacecraft where there must be really difficult environments to deal with, these parts are being printed now, and they're able to withstand whatever requirements are needed of the material and the structure. So it's amazing to me, but I think it's going to continue to pick up the pace, and we're going to see more of this. So that means maybe less material to remove, but additive materials can be interesting from the perspective of the compositions. They can get really creative to try to create whatever characteristic of the material that they want. Maybe they want to be very wear resistant, so the material might be very abrasive. There might be high levels of a certain material that is gummy and creates problems for the cutting tool. So I think there'll be some different cutting tool needs in the future for additive. And I think to tell you what that is, I can't right now, but we are starting to get more involved in that area, and it's quite interesting. So looking at the cutting tool solutions, I'm going to focus mainly on rotating solutions. So the spindle rotating, not necessarily the like a lathe spindle type environment. So we'll be looking at some milling and hole making tools, and we feel we have some very nice modular options that are robust and that can help out. And we're going to start by looking at some milling solutions that we think can make a difference. So looking at picking a milling tool, based on the diameter of the tool that you're looking at, there's a big overlap of where you have this choice to choose between solid carbide and an interchangeable or a modular system or indexable system. And operators and programmers are faced with this selection or this choice or decision-making process multiple times every day, and for each part or component. And you start looking at what diameters do you have that choice? Well, Iscar is pushing the boundaries of that, which you'll see here in some upcoming slides. But basically, from about 1/4 of an inch up to 1.25 inches, maybe 1.5 inches, depending on certain types of tools, you have this decision between solid and indexable. And I just want to take a look at, through the lens of utilization. I'm doing a benchmark here on a 1/2 inch diameter tool. I'm taking into consideration that we're machining a middle of the road ISO P material group, like a 4140 or a 4340, for example. And I'm just looking at this through the lens of utilization and what we see a lot of times in the market, especially on these light duty spindles. So you have carbide that's in this instance that's used to create the tool. And for a solid carbide tool, which I'm benchmarking here, we got almost a half a cubic inch of solid carbide rod that was used to create that solid carbide 4-flute end mill. And then when I look at the tools towards the left, in the middle, I have a multi-master interchangeable solid carbide. And then I have on the far left a multi-master indexable tool. And you can see the cubic inches of carbide being used in those two tools are much less than the benchmark of the half inch. And I'll put some percentages to give you the perspective coming up. But here's the idea, is that if I take the mean operating parameters that I would run in that 4340 material, you know, the speed, the feeds that the tool's capable of, and in this case, I just benchmarked as a full slot type scenario. And I said, okay, this is a tool that's capable on the left of 2.7 cubic inches because it's limited by depth of cut, a maximum of 130 thousandths. And then I've got the tool in the middle, which is that solid carbide interchangeable that has a little more depth capability, up to 3/8. So its maximum or optimal metal removal rate would be about 9.9 or 10 cubic inches. And then a solid carbide, if you're fully utilizing it, using the full flute, full width of cut, with similar cutting parameters, feed rates, speeds, you'd be looking at 26.4 cubic inches. But what do we typically see in reality is we see people utilizing even up to solid carbide end mills where they're just using the tip of the tool. How many of you picked up a solid carbide end mill or use a solid carbide end mill and that bottom 100 thousandths is chipped out or worn much more, if not, you know, the rest of the end mill might not be worn at all on the flutes. So this is what we see in reality. And when you look at it, you know, because of the constraints of designing an indexable tool, maybe one less flute, maybe more, but in this case, a 4-flute half inch has one less flute on the indexable version. So if I'm running at those optimal feed rates by the design of the tool, I might get a little bit more cubic inches of material removal rate, but when you're at that light depth of cut, you know, you're not fully utilizing the tool. There's a lot of waste there. And when you think about it from the sustainability side, you know, the multi-master solid carbide is using 74% less carbide to do that job. And an indexable version would be using 99% less carbide, less natural resources. So when you get into the sustainability aspect of this, if you can do almost as much or the same and match up that tool better to that light depth of cut application, you're using 99% less natural resources to do it. And, you know, I'm not getting into the other variables of the cutting tool's impact on a process, such as, okay, we have to look at cost or the price of the tool. We have to look at the different aspects of, you know, how that tool can be applied and what it can do. Does it have, you know, variable options that you can employ and maybe change grades of inserts and things. So there's a lot to get into, but we're just looking at this purely from how much carbide am I using to conduct or perform a given process. And when we get to the light duty spindles and with the additive manufacturing, there's going to be a lot of those light radial or axial depth of cut applications facing us in the future. And you can see where it could be a benefit to apply that modular technology or the multi-master system to do those operations. So just a quick overview of what multi-master has become. This is a system that's been in the market for more than 2 decades. Iscar had introduced it just before I came to Iscar. And so when you look at that system, it's a system of different shanks, steel, heavy metal, solid carbide, and various different solid carbide interchangeable heads. This is what everybody knows about the system. But what's kind of unknown about the system, or not as I guess popular in the market that should be, is these indexable. It's a steel body that takes indexable inserts, and there's a wide range of options that you can use to get to that using less carbide to do as much or more. And so when you look at the system overall in terms of the different types of tools you see here, you've got profiling tools, plunging tools, high feed tools, which have become a really popular way of performing rough machining applications. And then you got the 90-degree end mills that'll be more popular for these light duty machines and light depth of cut type scenarios, threading tools, slitting and slotting. So just a lot of options there to put on these steel or carbide or heavy metal shanks that you're investing in. But we're going to talk about some more unique options on how to improve those assemblies moving forward. Next, I'm going to move into some drilling options and making some comparisons. And that same decision-making process exists with the hole-making products. Do I take that solid carbide drill, and there's reasons for it, or do I go to this interchangeable replaceable head type system that Iscar calls Sumo Cam, and some of the other systems that are out there that are of a similar type interchangeable or exchangeable head design. So if I'm looking at the sustainability aspect again, I'm comparing 1/2 inch to 1/2 inch, and we're taking that ISOP material group, cutting speed and feed per revolution for the drill. And if I look at the carbide volume to produce that tool, I've got 0.73 cubic inches of carbide rod that I use to create that standard drill. And for that same diameter head in the Sumo Cam, I'm only using 0.022 cubic inches of carbide to produce that drill tip. So when it comes right down to it, you look at the performance, speed and feed per revolution. Yes, the solid carbide tool is a little bit more capable in terms of feed rate capabilities. You can see here I'm comparing that. If I'm looking at how I would apply that tool in the same material, I'd be running pretty much comparable speed, but the feed rate would be just slightly less, maybe 1 thou, maybe 5/10 per revolution less. So I have 2.9 cubic inches compared to 3.4. But when you really look at, you're using 97% less carbide, it becomes a no-brainer. This is a system that's been in the market now for many, many years. I think at least a decade, maybe more, maybe a little less. I'm not sure the exact launch date of this product, but it has quickly become one of the most common hole-making products out there in the market. And if you look at that 97% less carbide, and then you couple it with what I'm showing here on this slide, which is a 1/2 inch body. This is a 3x drill, and the example from the previous slide was comparing 3x solid carbide to a 3x Sumo Cam body, by the way. But going into looking at this 1/2 inch Sumo Cam drill, it can take 10 different head types. And when you start talking about that sustainability or utilization, imagine trying to use solid carbide drills to adapt to different geometries for material, whether it's ISO-P or ISO-M for stainless or ISO-K for cast iron. Having the ability to go from maybe a standard drill tip design, like a 140 degree point, which is very common in the market, to something that gives you the ability to self-center, like a self-centering head, like our QCP type heads, and then looking at double margin heads. So there's all these flat bottom heads. There's all these options that you can incorporate into that drill body. So you have this one drill body alone can have 50 different combinations. So start thinking about coupling that with, the range of drill bodies that you have available from 1.5 times D up to 12 times D, and maybe even longer for special circumstances. But you have so many options here, and that those 10 different types of heads are available in 4,000 increments, 5 different diameters. So this is a 1/2 inch comparison. I can tell you this drill body would take a 492 diameter head, a 496 1/2 inch, then a 504 and a 508. So that's where you get the 50 different combinations, because you got 5 different diameters for each head. So think about being able to, I don't need to drill a 1/2 inch hole specifically. I need maybe 492 because I need to maybe bore or ream the hole for accuracy's sake. Now I've got the perfect head combination to leave just the right amount of material for that operation that'll take place after. Or maybe it's a through hole and it's not very critical. Well, I need a 508 head and I'm just creating some clearance for whatever the feature is. Ultimately, it's like I said, it's a no-brainer as far as the amount of carbide and looking at the sustainability aspect that this system provides in terms of using way less carbide to get much more done. So kind of putting a bow on the assemblies is looking at the tool holding solutions. You can have the cutting tool, whether it's a drill body or the multi-master system with the shank. But you can start looking at some of the solutions, the specific tool holder solutions that can make you even more productive in these light duty spindle environments. And of course, integral tools like what you see on the left of the screen here is a great way to go to keep things rigid, robust in terms of gauge length, and being able to just really make the most of that particular assembly. But a lot of people like the versatility of maybe using an ER type system, or whether it's an integral ER system or an ER collet, which I'll highlight here in a few slides. So some of these ER systems that you see in the middle that have the multi-master connection, they give you that ability to have a really short gauge length if you're in like a tight environment like a Swiss machine, or you want to just maximize your rigidity because you want that really short gauge length. And then there's, it's kind of like the short, medium, long approach, and being able to have that versatility and change things up as you need to get more reach. And then over on the right, there's what we call an ER ODP, and ODP is the similar ISO M connection. It's just a metric thread with a pilot, which is more of a slip fit connection. So it's not as accurate, not as robust as the multi-master, which has a slight interference fit connection. But the ISO M connection has been in the market for a long time, and so we still create these tool holders to try to optimize those styles of tools. So looking at the ERODP, moving forward, I'm sorry, I got ahead of myself. To show you the kind of the versatility of these integral holders and the ER to multi-master connection, start thinking about, you couple that with all the solid carbide interchangeable heads, and then look at these indexable options that go with it, and you can start to see the picture of just how much versatility and how many different machining applications you can get to or accomplish with this type of system on these light duty spindles. And then looking at the ODP, another unique fit here that I'd like to point out is we've came out with this Sumo Cam to ISO M connection type drill body, and the range is from 236 to 823. And if you think about all those different types of heads, maybe you're thinking about a lathe that you have one tool station because you're limited on your number of tool stations in your turret. You can actually set up this ER to ODP, and you can just quickly change from a 236 drill to an 823 or something in between on that same station. And it just makes it really quick and easy to make those changes. Or maybe it's more about, having multiple tools, redundant tools, and then you just quickly, you change the head offline, you're keeping the machines running, you start looking at your operating efficiencies, that OEE. With tools like these, that's probably the biggest benefit to any of these modular tools that people should be keeping in mind, is not only the sustainability aspect and utilization, using less carbide, making the most of your investment, but from the aspect of manpower, I think many of you would have probably experienced that, in manufacturing, there's a lot of people that are going into retirement, and there's not as many people from the younger generations coming into manufacturing. So one of the challenges that any manufacturing technology supplier or manufacturing company is facing is, how do I keep machines running, or how do I keep production going, whatever it is. And these modular systems that are accurate, that make it easy, you could train somebody in a matter of minutes on how to, change out a tool or change a head or a drill head or a milling head and keep a machine running. So that's another aspect to keep in mind with having the right tool holder and cutting tool combination on these machines. And of course, looking at just the standard type tool holders that are out there in the market, I won't spend too much time here because I'm sure most of us are familiar with these, but your standard BT30 face contact for ER type collets, for shell end mill adapters for tool holders that go with that, shrink, very popular for employing small tools where run out and accuracy is so important to getting good tool life and avoiding catastrophic failures or tool breakages. And then hydro is another very nice option in these environments. So these are all things that, a cutting tool supplier like Iscar is recognizing the need for and keeping this in the market and available, so that as we see more and more of this type of machining and light duty spindles in the market, we can meet the need. And then I'm going to finish off by just highlighting something that's kind of attention to detail type stuff, but it's sometimes overlooking the smallest thing in a process can be the reason for failure, so to speak, or the root cause of failure. And when we look at an ER collet, it's one of the most common methods of holding all these tools in these different machine environments that I've highlighted. And there's been some things recently that you see out there in the market that cutting tool companies are doing to try to make things more robust and more accurate. And the ER collet is one of those things. And so if you look at what I have pictured here on the bottom of the screen, you'll notice there's 4 little holes in the face of the collet. That's for coolant delivery. So we're having sealed collets that get coolant to the cutting edge more precise and in more volume. And then you look at, collets used to be, for the most part, an ER collet or a spring collet used to have a range. Maybe it was a 20 thousandths range or a 40 thousandths range, but it was a collapsible range collet. And now what we're doing is we're moving away from that to exact size. So if you want that accuracy, you want that robust clamping force to make sure that the tools aren't moving, whether it's rotating or pulling out, the exact size collet's the way to go. And just to kind of give you an idea of accuracy and what takes place out there is that, your typical collet's going to provide you with a maximum run out of a thou. And some of the things that we've done recently improve that. We've had the Iscar standard for a long time that was probably 3 or 4 times better in terms of accuracy, and that projects to tool life increases, maybe 10%. When you look at these more modern collets, we're seeing differences of up to 45%, maybe even more, just by paying attention to that small detail, the collet, the interface of how it's holding the tool, and making sure that these smaller tools are running as accurate as possible. Because you think about the feed rates that you program really small tools at. I mean, if you get down to the really small end mills, the feed rate might be a couple tenths per tooth. So if you have a couple tenths run out, you can easily see how you can overload the tool, the cutting edge, and have premature failure or breakage. And the same goes to even these small indexables that are in the 1/4 inch to the 1/2 inch range, and even moving up. The more accuracy we can get, the better off we're going to be. So having said that, I think I've reached the time here today, and I think we're going to open it up to any questions that come to mind. I hope everyone's gained something from this, and we look forward to seeing you out there in the market. Thank you.
Awesome. Thank you, Tom. So yes, we do have time for some questions. So heading to the audience, it looks like Patrick wants to know, on the Sumo Cam line, how often would he have to replace the drill bodies?
So it's a little bit of a gray area because it depends on how hard you're pushing the body. I would say if you're looking at the mean, you might be looking at anywhere between 30 and 50 head replacements before you'd want to start looking at or paying attention to is the accuracy of the connection still there when you put the drill head on the body. And those are some of the things to look for. We have some environments, if you're machining aluminum, for example, you might get hundreds of head changes before you start to see wear, but it's definitely a connection. So connections wear, and it's something to be mindful of, that if you just continue to every once in a while throw that dial indicator in there and make sure that you still have accuracy on the drill head when you're putting it or mounting it in the body. And obviously there's a feel thing there as well. If you start to feel like you're not getting any tension in the connection at all, then you realize you're starting to lose that clamping accuracy and that clamping force.
Awesome. And does that change anything if he is using super alloys in the process?
Yeah, super alloys are more difficult to machine. They're going to put more stress and strain on the cutting tool itself. And I would say that it's definitely something to consider in your in your life of the body is, okay, if I'm machining super alloys, I might not get 30 to 50, I might get 20 to 40 or 20 to 30.
Awesome. Thank you, Tom. Also, Darren wants to know that if a drill body is not carbide, how does that work with shrink fit holdings?
It depends on the shrink fit system you're using. Induction shrink can take a steel tool. It's the speed at which it can apply the heat to the tool holder, and so the tool holder will heat up faster than the drill body will. So you'll have that release, or you'll have the ability. It's more about a lot of times when you're shrinking steel into a tool holder, it's not so hard to get it in because the tool's cool when you're putting it in, but then you go to take it out and sometimes you see people have struggles. I would say that, we offer both a round shank type version in our Sumo Cam and a flat type version of the shank in Sumo Cam. And you obviously would want to use the round if you're gonna, and you need to be using induction shrink methods, not something that's thermal. If you're using thermal, the expansion it'll be too slow, and the drill body shank will be heating up at the same time the tool holder is, and you'll never get the thing out. So
awesome. Well,
it's a
Tom,
one-time deal, Jake.
yeah. Another question from me is, I know if you have a possible customer or even an existing customer that might be wanting to get new tools, if they wanted to see these in action, is there any place that they could kind of, like I said, see it in action or get kind of a firsthand experience of these tools working?
Yeah, I think if you go to Iscar YouTube channel, we're like many other technology suppliers out there in the world. We're making video content and putting it up there as fast as we can because people are visual learners, and you type in Sumo Cam or Multi-Master or any of the items like I was showing in the presentation, and you'll see examples on our YouTube channel.
Awesome. Well, Tom, that just about wraps up today's presentation. So thank you again, and thank you to Iscar. Iscar is a full solution provider of metal cutting tool products and accessories for CNC machining, launching hundreds of new products for machining each year. Iscar is where innovation never stops. So, Tom, thank you once again. Always a pleasure, and I'm sure that we will be talking again soon.
All right, Jake. Thank you again, and have a great day, and we'll talk soon.
We'll see you. You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.